MakerSnack. Installing the Mosquitto MQTT broker on a Raspberry Pi, and using MQTT to control a CircuitPython-powered moving sound-playing robot. Part of the tutorial series on building Mil Mascaras, a PPE mask distributing robot friend.
Please take a mask. They're free and they keep us safe.
Alright folks, we're in the last step of building our bot, and once we're done we can turn on the bot whenever we want and control it with our iOS app. So let's go! Now first, a little bit of background on how things are going to work and what we're going to be doing. Now our app and our bot are going to communicate with each other using a standard called MQTT. MQTT is a very popular communication standard. It was originally developed by IBM, but it's now open source, and MQTT stands for Message Queuing Telemetry Transport. It's simply a lightweight, meaning low overhead, way to send and receive messages. Because it's lightweight, it takes up very little space on devices, and it takes up very little bandwidth when messages are sent back and forth. So it's especially useful for the Internet of Things. Now, there are three important pieces for MQTT to work. There's a broker, there's one or more publishers, and there's one or more subscribers. Now, the idea behind this is that a subscriber tells the broker, hey, if any particular messages come in on a topic that I've subscribed to, send them my way. Now, the publisher can publish messages, and if they're on a topic that's been subscribed to, the broker will send out that published message to all of a topic subscribers. So to give an example, let's imagine we have a temperature sensor and we have a heater. Well, the heater might be a subscriber and say to the broker, hey, I'm going to subscribe to the topic temperature changes. Let me know when the temperature has changed. Now, if the temperature sensor publisher publishes a message that the temperature has changed, the broker looks at the incoming message, it checks its list of subscribers, and it sends a message on to anything that's subscribed to it. So the heater subscriber will receive any temperature updates, and the heater might have code on it that says, hey, if the temperature falls below a given value, turn the heater on. So think about this in terms of the Internet of Things. You might have sensors and devices that act as publishers and that detect things like, is a door open or has the sun gone down? And you might have a bunch of different subscribers, say an alarm, maybe a display that shows temperature and weather, maybe a lamp. And you could have multiple different subscribers to the same topic. So the heater might subscribe to temperature, and weather station might subscribe to temperature changes too. So when the change of temperature happens, it's published to the broker, and the broker says, hey, who subscribed to the temperature messages? Oh yeah, the heater subscribed, and the weather station subscribed too, so it can update its display. Now the alarm might subscribe to messages about whether or not a door is open. If the door does open, the door publishes the door open message. It goes to the broker sees the alarm subscribe to the door open message, and the alarm might sound. And the lamp might subscribe to a message to be notified if the sun goes down. The light sensor publishes the message, the broker picks it up, sends a message onto the light which subscribed to this message, and depending on how the light was programmed, it might turn on or off. Now what does this all mean for our robot project? Well, we need a broker, so we're going to download an open source broker program called Mosquitto, 2 T's for MQTT, get it? And also we need a subscriber, and what we'll do here is we'll write a Python program that acts as a subscriber, and we'll call that control-pybot.py. Now both of these things are going to run on the Raspberry Pi. Normally, if we'd have multiple subscribing devices that a broker is sending messages to, then the broker would be on a separate device, sort of like a distribution hub for messages, but in our special robot case, we only have one subscriber, which is the Pi, which is running the robot, so we're going to run both the Mosquitto broker to collect the messages and the subscriber Python program on the Pi. Now our iOS device has our app running, and that app is going to act as the publisher. So this is how it'll work. The Python program, which is a subscriber, is going to tell the Mosquitto program, which is the broker, hey, I want to subscribe to all the messages that are published on a topic called Pybot Move. Now I could have created different topics for different categories, maybe one topic for movements and one for sounds, but to keep things simple, I only created one topic, Pybot Move, and that can contain messages that are either movements or sounds. So what are these messages? Well, as the programmer for this app, I decided that the messages were going to contain words, and those words were going to be forward, backward, left, right, and stop to correspond to directions. Or the words could be numbers, and those numbers correspond to the name of MP3 files that are in our sounds file that we'd copied over in an earlier video. Remember, those sounds are named from 0.mp3 to 11.mp3. So when we interact with the app, a message is published on the topic Pybot Move, and the Mosquitto broker is always listening for messages. It picks these up, and it sends them onto the Control Pybot program that's subscribed to these messages. Now, depending on the contents of the message, it'll either move the robot by triggering code to move the motors, or it'll play a sound. So for example, if we put put our finger down on the up button in the app, as soon as we do that, the app sends a PyBot move topic message with the contents forward to the broker. Now the broker looks to see who subscribed to PyBot move. It sees the Python program is subscribed, so the broker sends this PyBot move message on with the contents forward to the Python program. The program receives the message, it takes a look at its contents, and I've written the code so that when it sees the word forward, it will throttle the motors forward with a positive value. Now when the user lifts their finger from the arrow button in the app, a PyBot move stop message is sent. The broker picks this up, it sends it over to the Python program subscriber, and the Python program sets the motor throttle value to 0, stopping the bot. Now it'll do something similar if you push down on the button and then release for left, right, and back, and if a sound is tapped, the app publishes a PyBot move message with the number corresponding to the sound file to play. The broker picks that up, forwards it onto the Python program, which sees the Python move message is now a number, and it'll play the MP3 file that has the same name as that number.
I'm Mil Mascaras, robot of 1,000 masks. And I'd like you to take one and put it on. Thanks.
Now that's it. Now you know how MQTT works. If you ever want to work on another messaging project using the Internet of Things, you got a nice head start. So now let's get things working. I'm going to assume that you followed along our earlier steps in the tutorial, maybe gone through the earlier videos. We're going to continue with our step-by-step tutorial guide, which you can find at gallagher.com/mil-mascaras. That's also linked in the description of this video, and then scroll down to the section titled Installing Mosquitto and Python Libraries to Use MQTT in Python Programs. Now I'll assume, as we showed in earlier videos, that you've got a Pi properly configured and running on your Wi-Fi network, you've got CircuitPython and Pygame installed, that your Pi is turned on, and so open the terminal program and log into your Pi. And with that done, return to the browser, and this line here will install the Mosquitto MQTT broker software on our Raspberry Pi. So copy it, return to the terminal, paste it in, and by the way, we've seen that the apt-get command will default ask you if you want to save the installation to your Pi's SD card, and that causes installation to pause until you type Y. If you want to pre-approve so that you're not asked and your installation doesn't pause, you can just put a -y after an apt-get command, and the installation will complete without needing approval. So I've pressed return. This installation took about a minute, then return to our tutorial document, scroll down and find this next command, sudo pip3 install paho-mqtt. Now the paho-mqtt library is similar to the other Python libraries we've installed. This will expand commands that are available to us in the Python programming language, and this particular library gives us the commands to code MQTT messaging in Python. So copy this, return to the terminal, paste it in, press return, and it should install in under a minute. Now return to our tutorial and find the command system control is active Mosquitto. That verifies that the Mosquitto broker is up and running on our Pi, so copy that command, return to the terminal, paste it in, and press return. And you should see the word active, indicating that everything is working as expected. Nice! That's probably the first time you've ever wanted to see a Mosquitto. Now back in our instructions, we'll find the command that automatically runs the Mosquitto broker when we turn on our Pi, and we want to do this because we don't want to have to open up the terminal on a separate computer and log into the Pi to use the robot. We just want to be able to turn the robot on, open the app, and start controlling it. So the statement we want to make sure that the Mosquitto broker runs every time the Pi is turned on is this one here, sudo system control enable mosquitto.service. Copy it, return to the terminal, paste it in, press return, and to verify everything is working, you can stop your Pi with a sudo halt, turn off the Pi when the flashing green light goes off, turn it back on again, wait 30 seconds, log in again, and then we can return to our tutorial document and copy this command down here to verify things. System control is active Mosquitto. We've used this command before. Return to the terminal, paste it in, press return, and we see Mosquitto is active, even though we didn't do anything after logging in to start Mosquitto up. So everything is working great. Next up, we're going to install our subscriber program, the Python program named control-pybot.py on our Raspberry Pi. And we'll get this to run automatically when the Pi turns on as well. So over in our tutorial document under the section labeled Create a Subscriber Program to Listen for Robot Commands and Control Our Robot, we'll find the command to create this file in our nano program. That's this one here, nano control-pybot.py. Copy it, return to the terminal, paste it in, and press return, and Nano starts. Very familiar to us by now. And now let's get the code for this program from our GitHub repo. So back in our tutorial document, I'm going to right-click to open our GitHub repo in a new tab. I'm going to find this link for the file control-pybot.py, and I'm going to click on that. And here's all the code to run our client program that receives messages and controls our robot, moving the bot and playing sound through its speaker. And it's actually not very much code. It's amazing how easy it is to get a robot set up on the Pi. Now, like we've done with the other code for this tutorial, let me quickly talk you through what this program does, but first, a bit of information in case you have a Raspberry Pi which has a host name different from Mil-Mascaras. Now first, in just a bit after we get this program up and running, we're going to open the terminal program to simulate our app sending commands to this program. And we'll enter these commands that you see here, the ones that start with Mosquitto_pub. Now these are publisher commands, just like the one that our app is going to send. Now if you don't have a Pi named Mil Mascaras, where you see Mil Mascaras in here, you're going to want to swap in your own Pi's host name instead. Now you won't need to change the code in Nano. These are just comments in here to remind you of the code that we're typing in to test things out, but just keep this in mind when we enter these commands in the terminal in just a bit, and I'll remind you again when we get there. And by the way, the app is also written so that you can configure it with a new host name if you need to. But there is one change you're going to need to make in your code in Nano if your Pi has a host name other than Mil-Mascaras. You'll want to go down here in what is currently line 33, the one that says server address equals, and in quotes, Mil-Mascaras. And then in Nano, what you're going to want to do is replace Mil Mascaras with your Pi's host name. That's it. So now let me quickly talk you through what this code does. First, we import the libraries we need to extend the Python programming language for everything we want to do with our robot. So Pygame for sound, time to count off seconds, Paho for MQTT, and the Adafruit motor kit. Now, one other note, if you're using the Adafruit motor hat, not the Waveshare hat that I've been using in these videos, you're going to want to change this line that's currently line number 22. And instead of the parentheses having 0x40 inside of them, you want the parentheses to be completely blank. So an open and close parenthesis with nothing inside, not even a space. Again, that's only if you're not using the Waveshare hat that I'm using, but instead you're using the Adafruit hat. Now down here, we do some additional configuration. We set a client name for communication between our broker and our program, and the server address, which is the Pi's host name. Now if when you're running your bot, you find that your bot pulls a little bit to the left or the right, one motor is faster than another, you can tinker with these left or right trim values. These values are added to our speed, so if one motor is running a little bit faster than the other, you can open this program back up in Nano. You can add a negative trim value to the side that's running too fast to slow things down and try to even things out. And you'll always go negative. You'll never add a positive trim value because you don't want to increase the speed past 1.0, which is the maximum speed. Now, slow turn by is a constant that I use to set the turns to happen at 50% the maximum throttle. You can fool around with this value if you want faster or slower turns. Then we've seen this chunk of code before. It's the same code that we used in our sound demo Python program from an earlier video when we were testing playing MP3 files. So this is just setup code to play our sound files. Now down here is a function to show our connection status. Normally you won't see any messages printed out when you use your robot because you're going to be controlling it from an app, not from the terminal. But for our demo, I've written code to print out messages when we test this program for the first time so that we can see that we've successfully subscribed to messages on the topic pybot/move. And now this code that starts def message decoder is where most of the action is. So this is a function that takes a look at any message that comes in on the topic that we've subscribed to, and in this code it's pybot/move, and this set of if-elif statements responds to different possibilities. So if our message is forward, we move forward at full throttle 1.0, stop throttles our speed back to 0, backward we'll throttle at negative values, left and right have one wheel positive, the other wheel negative so that the bot spins. Now there's also a setting for volume. I didn't mention that in the earlier animation, but we can also adjust the volume setting for sound play from the app. Now messages to set the volume start with vol equals and a number. So what I do here is I check to see if the message starts with vol equals, and then I strip that part out and then use just the number to set the speaker volume. And if the message that comes through isn't one of the 5 directional messages and it doesn't have vol equal in front of it, then the lines after this else statement are going to assume that a number was passed through. And again, in our code, the number represents a sound to play. Remember, the files that we copied over into our sounds directory in an earlier video were named 0.mp3 through 11.mp3, so we just take the number as text, we append .mp3 to the end of it, and we play that file. Now there's just a little bit more code here at the end that executes everything, so this is how we connect to the broker. This is how messages are decoded in the function that we just looked at. This is how we connect to our Pi's host name, which is the server address. And instead of having the traditional while true loop that you see in many introductory Python programs, with MQTT we can just use this loop forever statement and the code will run forever and ever as long as the bot is on. And that's it. And even if you're not a Python programmer, you can probably look at these statements and get a rough idea of what the code is doing, and you could probably even go in and do some simple modifications too if you wanted to. Now feel free to use this as a template if you ever want to write your own MQTT programs in the future, but now let's get this code on our Pi. So we'll highlight all of the code from the last line through the first line, copy it, return to Nano, and paste it in. Now just a quick reminder, if your hostname is not Mil Mascaras, find this line toward the beginning of this code and swap in your hostname between the quotes. And if you're using the Adafruit motor hat instead of the Waveshare hat that I'm showing in the videos, find this line also toward the beginning of the code and remove the 0x40 between the parentheses so there's nothing in between there. For everybody else, and for those who just made these modifications, we can now save this program, so type Control-X, yes to approve, return to accept the name, and we have bot controlling code. So now let's run that code. We'll head back to our browser. I can close this tab with our GitHub code. We don't need that anymore. And you know the command you need to type in to execute this code. It's this one right here, python3 control-pybot.py. So highlight that, copy it, return to the terminal, paste it in, and press return. Now we start to see some output. We see a standard message that shows up when we run a program using the Pygame libraries, and we also see a message confirming that we're trying to subscribe and that we have subscribed. And so this Python program is a subscriber. And if you go back and look at the code that we just entered, you'll see the subscriber is waiting for messages on the topic pybot/move. Now this Python program is in a continuous loop, so we won't be returned to the terminal here as long as the program is running. But if we return to the instructions page, there's information on what we're about to do. You'll find that by scrolling down to this section here that says open a new terminal window, and then as a test, write a command to publish, a command to move our robot. And what we're going to do is we're going to open another terminal window, and from this new terminal window, we're going to log back into the Raspberry Pi. This way we can send commands to the Pi without having to cancel out of the control Pybot program that we just started running. And once we're logged in, we're going to enter commands that mimic the exact commands that our iOS app will send to the Mosquitto server on our robot. Now the first command that we're going to enter is going to be this one here to play a sound. So highlight and copy this, and to read this, it says, hey, this is a Mosquitto publisher command. So again, this is a command coming from a publisher when it's ready to publish a message on a new topic. Now we see it's sending it to the host, Mil Mascaras, so that's where our Mosquitto server is. If your Raspberry Pi has a different host name, make sure that you swap that out instead of Mil Mascaras here. Now the topic is pybot/move. Remember we mentioned that in our Python code. And this last thing in quotes is 0. Now that's our message, the message that's on the topic pybot/move. So the Mosquitto broker is going to receive this published message. It'll take a look to see who's subscribed to this. The only subscriber is going to be our control-pybot Python program. So the Mosquitto server will send this message to the Python program. That program will look at the contents of this message. It's going to see a 0, and it'll play the file named 0.mp3 out of the speaker on our Raspberry Pi. So with this message copied, return to the terminal, and we can open a new terminal window with Command N, and that keeps the control Pybot program still executing in the terminal session in the back window. In the current window, I'm going to say Shift Command plus a few times to increase the font size, and with this new terminal window, I'm going to log back into Mil Mascaras, and now let me show you my robot. Now, I put the robot up on a box so that the wheels aren't touching anything, and the reason for that is the second command I'm going to show you is going to be the forward command, and that's going to start moving the wheels forward, and I don't want the bot to shoot off my desk because it's going to keep moving forward until I retype another command to tell it to stop. Now I've also turned on the speaker because the first command I'm going to enter is going to play a sound file. So let's paste this command in, listen to the bot, and when we press return...
I'm Mil Mascaras, robot of 1,000 masks, and I'd like you to take one and put it on. Thanks.
Oh, how about that? We just sent an MQTT program to our Mosquitto broker. Our Mosquitto broker sent that message to the subscriber, which is our control Pybot program, and that program played the sound. Nice! Now let's mimic what would happen if our iOS app sent a message with a 9 instead of a 0. So I'm going to press the up arrow on my keyboard. This shows the last command that I entered, and I'm going to change the 0 to a 9. Now listen up. Press enter.
Dude, what's wrong with you? The mask goes over your nose.
And oh yeah, we're trolling the germ spreader who doesn't nose mask. Way to take a stand, robot! Now let's try some commands that run the wheels, and these are a bit tricky because as soon as we enter a forward command, the motors are going to continue to move forward until we enter a stop command. So this is what I suggest. On our instruction sheet, let's highlight and copy this command. This is the command that's going to send a forward message, and if you take a look at it, the only difference between this command and the commands we entered earlier is the word forward is in between quotes. Then let's return to the terminal, and we'll paste in, but do not press return yet. We've pasted in the forward command, and now head back to the instructions page, and what we'll do is we'll highlight and copy the stop command that's just below it. Now if we head back to the terminal page, we've got the stop command on the clipboard to paste in as soon as we want to stop things after stuff is moving forward. So now that we're back in the terminal, it's not a bad idea to have one hand on the bot just in case the wheels are touching the table. You don't want your fast-moving bot to shoot off the table when it starts moving forward. And now I'm going to press return. And my bot wheels move, look at that. And to turn it off, I'll just paste in the stop command and press return. And the bot stops. Nice work. The bot is receiving instructions. Now all we need to do to finish up the robot part of this project is to make sure the control PyBot program runs automatically each time the Pi is powered up. Now before we do that, why don't we close our current terminal window. So I'm just going to click on the left traffic light in the upper left-hand corner of this window and click Terminate. And we still have the original terminal window open, and this is where our Python program is executing. Now normally we won't see the output that we see down here because the PyBot will just run without the terminal program being open, but if we take a look at the output that we see here, we can see the name and the location of the two MP3 files that we played. We can see that we issued a command to move forward, and both wheels moved forward at 1.0 full speed, and then we issued a stop command. Cool. And these statements that printed out aren't things that you get automatically. I actually wrote our control pybot.py program so that it does print out these statements when it receives commands. But now I'm going to stop this program, and you can stop any Python program by typing Control-C, and you get a bunch of text above this keyboard interrupt statement indicating where the program stopped. None of this is important to us, but we are returned to the prompt, and that's what we wanted. So let's head back to our instructions in the browser. And now there are a few ways we can create a Python script that will execute at startup. And here the technique we're going to use is to create a service script. Now this line here starts Nano creating a script at a location where our Pi looks for these scripts. And we're going to call this script pybot-mqtt client.service. So highlight and copy this entire line, return to the terminal, paste it in, press return. Nano starts up, then return to the browser, and I've already got a copy of the script that we need in our GitHub repo. So why don't you click here to head back to our GitHub project page, and then find the link to pybot MQTT service and click on that. Now here's our script, and if you're curious about the script, we can see that it executes after the Mosquitto service starts running, so we want to make sure Mosquitto's up first, and it's going to run Python 3 with a script which is in the directory home/pi, which is the directory that we get when we first log into our Pi, with the script name control-pybot.py. It's always going to run whenever we restart our Pi, so this is good. Let's highlight all the lines, copy them, return to the terminal, paste them into Nano, then we can Command X, yes, return, and you've got yourself a service script. Now we just need to enter a system control command to run this script. This is similar to a command we executed previously to run Mosquitto every time our Raspberry Pi starts. We want this command here, sudo system control enable pybot-mqtt client.service. That's the service script that we just created in Nano. Copy this, return to the terminal, paste it in, and press return. And now to verify everything is working like it says in our instructions document, I'm going to return to the terminal and issue a sudo halt command. Then I'm going to completely quit out of the terminal so that the terminal session is not running. No terminal is up. Then I'm going to turn off my Pi, no power, it's definitely off. In fact, what I'll do is I'll switch over to battery power because this is how the bot is normally going to run. Make sure that the speaker is on. It is. I can see the green light. And after about 30 seconds, we're going to hear the startup sound.
Ready to roll. Let's go.
Excellent! So all is working perfectly. We no longer need a terminal session to get our bot up and running. We just turn it on and it's ready to accept commands from our iOS app. So bot builder, your bot is done. Now all we need to do is to get that iOS app running, and we'll cover that in the next video. And there are already instructions in the tutorial document. Now I hope you enjoyed this series and found it useful. If so, I would really appreciate it if you'd like and subscribe, since this really helps more people find the YouTube channel in YouTube search. And please share this channel with your STEM educator friends and any other students or makers who you think might enjoy this. I love hearing from people who use this material to build stuff, so please drop a comment or send me a tweet. This is Prof G, and I hope you feel like you made something awesome. Keep at it.